Hello everyone, welcome back. This is Mr. Hussein Wasapi, and in today's video we'll be solving a question from tutorial sheet 1 of physics, 1 or 2 of Mulongoshi tutorial sheets. Alright, so this is question 1b of physics tutorial sheet. Okay, so before we begin, don't forget to like and subscribe to the channel. Alright, so a light spring of an extended length of 14.2 centimeters is suspended vertically from a fixed point, as it is shown below. We've been told that a certain weight has been hung on the spring, creating some form of extension, which is given as 16.3. Now, we've also been told that an additional force F extends the spring to an extension of 17.8 centimeters. Now, we've been asked to show the spring constant is 1.8 Newton meter to the minus 1. So, one thing you should know is this. For starters, the question is wrong. We need to show the spring constant K is equal to 1.8 newtons per centimeters. Because if you try and do it, you will realize that you will not show it. So it's supposed to be centimeters. Alright, so now how are we supposed to go about this? Remember, force is equal to what? Kx. Our interest is the K value. So let's try and make it the subject of formula. So divide by x, divide by x. This implies that K is equal to F over what? X. Let's collect data and ask ourselves, what's the value of F? The force is the weight, because weight is the type of force. So this is 3.8 newtons. X represents the extension. Remember, length final minus what? Length initial. Length final is 16.3. So it says 16.3 minus the initial, which is 14.2. So, with this in mind, extension will then be what? If you get your calculator and punch 16.3 minus 14.2, you end up having 2.1 centimeters. With this extension and this force, all you have to do is now substitute in this formula. So, K is equal to the force, which is now 3.8 divided by the extension 2.1. If you do 3.8 divided by 2.1, you end up having the K value being equal to 1.80952381 newtons per centimeters. Now, basically, we need to round this off. Therefore, K is equal to 1.8 newtons per centimeters. This can also be written as K being equal to 1.8 newtons dot centimeter to the minus 1. So we can say, hence what? Shown. As simple as possible. So, the next question reads as follows. Okay, so I've been told that for the two extensions, which is 16.3 and 17.8 centimeters, we need to calculate the change in gravitational potential energy of the mass that has been hung on the spring. So, to do this, it's not that difficult at all. Remember, change in gravitational potential energy is equal to mg change in what? H. So the change in gravitational potential energy is dependent on the final length. So we say weight by the change in what? Length what? Final. So the change in gravitational potential energy is basically the weight multiplied by length final 2, which is this guy here, minus length final 1, which is the one here. So if we do our computation, we say change in gravitational potential energy is now equal to the weight, which is 3.8, multiplied by length final 2, which is going to be this one, 17.8. So it says 17.8. Since it's in centimeters, we need it to be in what? In meters. Now, just because we solved, or had to show that our spring constant is 1.8 newtons per centimeters, doesn't necessarily mean that everything should be in centimeters. It was only for that question. So, in this case, whenever you see centimeters, convert to what? Meters, because that is the standard. So 17.8 divided by what? 100 minus 16.3 divided by what? 100. So you have the change in gravitational potential energy being equal to what? 3.8 multiplied by 0.178 minus 0.16 what? 3. So the change in gravitational potential energy is equal to what? 3.8 times 0.0105. Therefore, we could say the change in gravitational potential energy is now equal to what? 0.057 what? Joules. As simple as that. Alright, let's move on to the next question. Okay, so the question says, show that the change in elastic potential energy of the spring is 0.077 joules. Okay, so remember the change in elastic potential energy, PES, is equal to half K change in extension squared. So the change in elastic potential energy S is equal to half the K value, so let's put K for now, then change in extension, so we have extension 2 squared minus extension 1 what? Squared. This is extension 2 and this is extension what? 1, don't forget. So what we'll now do is this. Let's find data for this extension. Let's start with extension 1. Remember, extension 1 should equal to length final minus what? Length initial. This is extension 1, the first extension. So extension 1 is equal to length final, which is 16.3 minus length initial, which is 14.2. Extension 1 is equal to what? 2.1 centimeters. But now we need to convert it to meters, so divide by what? 100, and we end up having 0.021 meters. So this is for extension 1. So that's our data 1. So for extension 2, let's call it data 2. So x2 is equal to length final minus what? Length initial. This is the final length, and we know the initial length. So we just say extension 2 is equal to length final, which is 17.8 minus length initial, which is basically 14.2. If we compute this, this gives us what? We end up getting 0. Okay, let's not do it fast. Okay, if we do it, we end up having 3.6. Since centimeters divide by what? 100, and this gives you what? 0.036 meters. So now you have the extensions. You also need the K value. Remember, the K value was found to be what? 1.8 newtons per what? Centimeters. Now you need this to be in meters because the spring constant is always in what? Meters. So we say 1.8 to convert to meters, just multiply by what? 100. So K is equal to what? 180 newtons per what? Meters. With these values, all we have to do is now just substitute. So we say change in elastic potential energy is equal to half times 180 times 0.036 squared minus 0.021 squared. If you compute this, you end up having change in elastic potential energy to be equal to 0.07695 joules. So the elastic potential energy, the change in elastic potential energy is now just equal to 0.077 joules. That's shown. Let's look at the last question. So the last question says determine the work done by what? The addition of force F. So work done by the addition of force is simply just so work done is equal to what? Change in elastic potential energy minus a change in what? Gravitational potential what? Energy. So work done is equal to what? The change in gravitational potential energy, which is 0.077 minus the change in elastic potential energy, sorry, minus the change in gravitational potential energy, which is 0.057. If you compute this, the work done will be equal to 0.02 joules, and this will be the final answer. Alright, so you go about solving this question. It's a very interesting question. Try to go through it over and over again to understand clearly how to go about it. Thanks for watching. My name is Mr. Hussein Mosapi. Don't forget to like and subscribe. Remember to strategize before becoming a statistic, and let's try and push for that A+.